Hey everyone, and welcome to this one short video on probability. So, we're going to discuss the NCERT questions which are very important in this particular chapter. Also, we'll see some of the problems based on it as well. So, probability. Introduction. So, what is probability? Basically, probability is a branch of mathematics that deals with likelihood, right? When I say likelihood, that means chances, right? The likelihood of occurrence of events. So basically here we are talking about the chances of occurring. Like if I ask you, what is the chance of raining today? So you'll just analyze, think and give me some number, right? What is the chance of India winning a match between India and Pakistan? So that is the chance, that is the chances of the occurrence of event. Event is what? Like cricket match is an event. And in that event, two teams are playing. And then who will win is the chance. That is the probability basically. So it provides a way to quantify uncertainties and randomness. Obviously, it provides what? A way to quantify uncertainties and randomness. So the classical definition of probability is that this we have studied in our 10th grade also, that probability of some event, say event A, is given by number of favorable outcomes by total number of possible outcomes, right? So probability is nothing but number of favorable outcomes by total number of possible outcomes. Now some important terms in probability, right? The first term is experiment. So what is an experiment? So experiment is basically a procedure that can be infinitely repeated. It can be repeated as many times as possible and has a well-defined set of possible outcomes, right? A simple example, experiment. Tossing a coin is an experiment. Now see, when we toss a coin, can you exactly tell me whether you're going to get head or tail? We cannot predict, right? Until and unless the coin falls on the ground, we cannot say it's going to be head or tail. That is why we are saying here that a procedure that can be infinitely repeated and has well-defined set of possible outcomes. So there are possible outcomes here, that is head and tail. Similarly, if I talk about a match, a football match between any two teams, say for example Argentina and Brazil, then what are the possible outcomes there? The possible outcomes are Argentina might win the match, Brazil might win the match, or there can be a draw. So there are three possible outcomes, right? So every event, and what is the event? Event is playing a football match. So playing a football match is an event and outcome is the possibility there, right? Okay. Then we have sample space. So sample space is what? Set of all the possible outcomes, right? So when I say set of all the possible outcomes, just now we took an example of football match between Argentina and Brazil. So what is the set of all possible outcomes? Argentina wins, Brazil wins, and the third is draw. So three possible outcomes. So combined all possible outcomes gives you a sample space. Similarly, if I toss a coin, what is the sample space? This we have studied in our 10th grade also. So I don't think we have to discuss much on this. So if I talk about tossing a coin, as I mentioned, in tossing a coin, we have head or tail, right? Two possible outcomes that comes under the sample space. Then let us talk about an event. What is an event? An event is basically a subset. It is a subset of sample space, right? So subset of sample space is an event and a specific outcome or set of outcomes of the experiment. So that is an event. Now, if Argentina wins, that is the event basically, right? And if Brazil wins, that is also considered as an event. If I toss a coin, if I get a head, getting a head is an event. So all these come under the category of event. Okay. Now let us see some examples. So here we have drawing a card from a deck of 52 cards. So as we already know that in playing cards basically, there are 52 cards. So drawing a card, this is an event. So what is the sample space? The sample space is all the 52 cards. And how many sample points are there? Sample points means n of s 52, right? Because there are 52 cards, we can say that the number of sample points are 52, correct? Now what is an event? So let us say we have an event of drawing a red card, right? There is an event of drawing a red card. So how many cards are there? Total 52 cards. 52 cards are divided into 26 black and 26 red. So can I say this event can be an event which contains 26 red cards because there are 26 cards, red cards. So the probability would be 26 by 52, which is nothing but 1 by 2, right? Now let us talk about conditional probability. So this is something new for all of you. So let us talk about independent events first. So what are independent events? So event is not affected by any other events. So independent events are those events that are not affected by any other events. I'll give you an example here. Tossing a coin. Now understand. Now once you toss a coin, what happens? Either you get a head or you get a tail, right? We already know. Whenever we toss a coin, we get a head or we get a tail, right? So the past will not affect the current toss. So whenever the past is not affecting the current scenario, it is called as independent event. I'll tell you a simple example. I toss a coin, I get tail. Now if I want to toss the second time, does it matter what I got in the previous throw? Doesn't matter, that is gone. Again I have to restart it. So again if I toss a coin, I have options head or tail. So my previous throw is not bothering my current throw, right? So in that case, we can clearly say it is independent events. So if the first event is event of getting a head, the second event is event of getting a tail, they are independent events, right? They are not affecting each other. Okay, let's continue further. Let us talk about dependent events. So events that can affect, events that get affected basically. So the current events that get affected by the previous events. We'll take an example now. Now suppose there are 2 blue and 3 red balls in a bag. What are the chances of getting a blue ball? So there are 2 blue and 3 red balls, right? This is already given. So the question says, what is the probability? Chance means probability. What is the probability of getting a blue ball? So can I say the probability of getting a blue ball is number of blue balls divided by the total number of balls. So how many number of blue balls are there? The number of blue balls are 2. Total number of balls are 5, right? So here the probability is going to be 2 by 5. But now if I remove one ball, right? One ball is already drawn. And then if I want to find out the probability of blue ball here, is it going to be the same or is it going to change? This is going to change. That means here what I've done is, after getting a blue ball, basically I've not placed it back. So definitely this is affected by this, isn't it? So this is, both of them are dependent events, right? They are dependent events. Okay. Now the events are dependent, that is the chances change. So here basically if you see, there is a blue ball, right? And then if you put it back, it's going to be the same, right? So in such cases, since it is the same, if you are replacing it back, right, with replacement, the previous one was without replacement. In that case, they are going to be independent, right? Okay. And without replacement, what will happen? The chances do not change, right? The chance is not going to change. Okay. And when we replace it, what happens? When we replace it, that is we replace the ball, it is going to be the same. So they are independent events. But if we don't replace it, then definitely in that case, it is going to be dependent, right? So have a look at this. It is going to change because there is no blue ball here. We are not putting it back again, right? Okay, let's continue. So conditional probability is basically the probability that depends on the previous result. Conditional probability is a probability that depends on the previous result. A simple example is the same thing. If there are 2 blue balls, 3 red balls, what is the probability of getting a blue ball? You find out the probability of that. But if I ask you, in the second turn, we have got one blue ball. Now what is the probability of getting a blue ball? Is it going to be the same? No, it will change in that case, right? Okay. So due to this fact, they help us understand how events are related to each other, right? So mathematically, the calculation of probability of event A for which event B has already occurred. So the calculation of probability of event A for which event B has already occurred. So it is denoted by like this. So probability of event A for which event B has already occurred is given by probability of A and B. Here basically we see what is common and then divided by the probability of B which has already occurred. That is the event which has already occurred. We find out the probability of that. Then here A intersection B. A intersection B means what? Common between A and B, right? And then probability of event A for which event B has already occurred is given by probability of A and B by probability of B. You'll understand this better once we solve problems based on this. Okay. So this A intersection B represents the probability of both, right? A and B. This is called as AND, occurring simultaneously. Okay. And P of B represents the probability of event B which has already occurred. So conditional probability is the probability that depends on the previous result, as we know. Let us see an example. We flip two coins. What is the probability that both are heads given that at least one of them is heads? See, it is given that at least one of them is heads. Given that at least one of them is head means what? This is already given. That means this has already occurred, right? So this will be our probability of B. That will be our event B. Now we know that the possibilities would be HH, HT, TH. See, we are given that at least one head. This is already given. At least one head. At least one head means minimum one head. Maximum two is also fine. So that is HH, TH, HT. Right? HH, TH, HT. So can I say this is at least one head? Now it is given that at least one of them is head. What is the probability that both are heads? Now tell me one thing. Only one outcome has both as head, right? If I talk about this, correct? Now this is 1, this is 3, right? So here our probability would be 1 by 3. Why 1 by 3? Because the actual is 1 by 4, the whole by 3 by 4, right? 4 will get cancelled and then you will get 1 by 3, correct? Okay. Now let us see an example. We roll a 6-sided die. What is the probability that the roll is a 6 given that the outcome is an even number? Outcome is an even number. Okay. So if outcome is an even number from rolling a dice, first of all, this is the sample space 1, 2, 3, 4, 5, 6. So this is our event B, right? Given that outcome is an even number. So can I say the even numbers are 2, 4 and 6. So that is 3 outcomes. Then what is the probability that a roll is 6? 6 is only one time here. So can I say only one of this is 6? So this is, how do we write this? Basically we write it like this. Probability of A where B has already occurred, right, is equal to probability of A intersection B. So what is common? 1. So that will be 1 by 6 by probability of B, that is 3 by 6. So can I say 6 will get cancelled and you'll get 1 by 3, right? So 1 by 3 is the final answer. I hope this part is clear to all of you. Okay. Now let us see the steps to calculate the conditional probability. So identify the events first. Let's call them as event A and event B. We'll always have two events, event A and event B, and event A is dependent on event B. Also, event B is already occurred. Okay. Step 2. Determine the probability of event A. Then determine the probability of event B. Find out the probability of event A. Find out the probability of event B. Then basically this is more important. You forget about step 2 and step 3. Forget as in, that's fine. You need to find out this. This is more important. And of course, you need probability of event B as well. Then we apply the conditional probability formula and calculate the required probability. That is nothing but this divided by this. Okay. Let us see an example. So card is drawn from a deck of 52 cards. Okay, there are 52 cards. What is the probability that the card is a king given that it is a face card? Given that, whenever they say or use the word given that means this has already occurred. Imagine this has already occurred. That is going to come in the denominator. So you need to identify what will be your event A and what will be your event B. This part is going to be your event A and this part is going to be your event B, right? Okay. Let us move on to the solution. How many face cards are there? Obviously, there are 12 face cards. We know that there are 4 jacks. Then we have 4 queens, 4 kings, right? Ace cards are not face cards. So total there are 12, right? So these are 12 face cards, right? the probability of event B is 12 by 52. Probability of event B is 12 by 52. This is event B, right? Face card. Now we are going to talk about event A, which is a king, right? So how many kings are there? There are 4 kings, right? So now tell me, can I say all these 4 kings are already there in this 12? Because 4 kings will be there in 12 face cards, isn't it? So P of A intersection B, that is A intersection B basically, is nothing but A and B also you can say, is nothing but kings, right? So all 4 will be considered there. So can I say the probability of that will be 4 by 52? And what is the probability of B? Probability of B is 12 by 52. So definitely to find out the probability of this, probability of A where B is given, probability of A where B is given will be equal to probability of A intersection B, which is 4 by 52 by 12 by 52. So 4 by 12 will come, right? See here, 4 by 12. Ultimately 4 by 12. The denominator will get cancelled only, and 4 by 12 is nothing but 1 by 3, right? So 1 by 3 is your final answer. I hope this part is clear to all of you. Simple. Conditional probability. Find out probability of A. Find out probability of B. Main is find out probability of A and B. What is common in both of them. Then find out probability of B. Divide both of them. Get the answer. Okay. Let's continue. Now 2 dice are rolled. What is the probability that sum of the numbers is 8 given that the first die shows a number greater than 3? Okay. So first die shows a number greater than 3, that will be your event B. Event A will be sum is 8, right? So these are all the possible outcomes. Write down all the possible outcomes where the first die starts from 4, right? So 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6, right? Total 18 possibilities. Out of these 18 possibilities, we're talking about the favorable possibilities, that is A intersection B. Clearly here we need the sum is 8. Sum means addition. Addition is 8. So can you see here 4 plus 4 is 8, 5 plus 3 is 8, 6 plus 2 is 8. Correct. So can I say there are 3 possibilities here? Yes. So what will be the probability? You take 3 from here, you take 18 from here, you'll get 3 by 18. 3 by 18 is 1 by 6. Right? So 1 by 6 is your final answer. Correct. Let's continue. Okay. So now let us see some of the properties of conditional probability. The first property is the conditional probability of an event A given that B has occurred lies between 0 and 1. It is quite obvious, no? Because we are talking about the probability. Probability is never greater than 1 anyways. Maximum it can be 1. The least it can be 0. So probability, conditional probability also of event A where B has occurred is greater than equal to 0, less than equal to 1. Clear? Okay. Let us talk about the second property. So if A and B are 2 events associated with random experiment, then probability of A complement where B has already occurred is 1 minus probability of A where B has occurred. Obviously, this is same as your previous concept, right? If I talk about probability of A complement, what is probability of A complement? Probability of A complement is 1 minus probability of A, right? Let us talk about the third property. So if A is an event associated with the sample space, then probability of the sample space, obviously, where A has occurred, will be equal to the same as probability of event A where A has occurred, and that is going to be 1. It's quite obvious, right? Next property is if A and B are 2 events associated with a random experiment and S is a sample space, right? And if C is an event such that probability of C is not equal to 0, then probability of A or B where C has already occurred. Probability of A or B where C has already occurred is probability of A where C has occurred plus B minus A intersection B. Now this is again nothing new to you. You have already studied about probability of A or B in your lower grades. We know that probability of A or B, right? Probability of A or B is given by what? It is given by probability of A, right, plus probability of B and then minus probability of A intersection B, right? So this we have already studied, isn't it? Same thing here. Here only event C has occurred. That's it, right? Okay. Now please make a note that in particular, if A and B are mutually exclusive events, mutually exclusive, that is they are disjoint, right? Mutually exclusive, then this part will not come. Obviously, this will become 0, no? Because there is nothing common. If there is nothing common, that means it is 0. So just eliminate this part and see the formula. Probability of A union B or A or B where C has occurred is probability of A where C has occurred plus probability of B, right? And this is plus 0. No need to write down plus 0 there. Clear? Okay, let's continue. Let us talk about the multiplication theorem on probability. So if A and B are two events associated with the sample space S, then A intersection B is also represented as AB, right? A intersection B and AB is one and the same in this case, provided A and B are two events associated with sample space S and AB represents the event that both have occurred. In the previous one, only B was occurring. Here, A and B both are occurring. So, both have already occurred. Okay. So, P of A intersection B or P of A or B, probability of A and B is given by, understand this, probability of A and B is given by probability of B times probability of A where B has already occurred, right? But the second condition is probability of A times probability of B where A has already occurred, provided probability of A and probability of B here should not be equal to 0. Obviously, denominator cannot be 0. So, A intersection B denotes the simultaneous occurrence of the events A and B. Okay. And A intersection B is also written as AB, one and the same thing. Let us see an example. Find the probability of drawing a diamond card. Probability of drawing a diamond card. Recall 13 diamond cards. In each of the two consecutive draws, that means back to back. So back to back two events have occurred, right? Event A and event B. So definitely this is talking about multiplication. Event A is also occurring. Event B is also occurring. From a well shuffled pack of cards, if the card drawn is not replaced after the first draw. Card drawn is not replaced after a first draw, right? So here, let A be the event of drawing a diamond card. So we have an event A of drawing a diamond card and then diamond card in the first draw basically. And then B is an event of drawing a diamond card, right? In the second draw. In the first draw, see, find the probability of drawing a diamond card in each of the two. So every time we are drawing the diamond card only. So after drawing a diamond card in the first draw, 51 cards are left out of which 12 cards are diamond cards. Now understand how this is happening. How many cards are there? Total there are 52 cards. Total there are 52 cards. I'm drawing a diamond card. It's already a diamond card, right? So can I say one card is already drawn? Now, not replaced. That means that diamond card, I'm keeping it away. Now, how many cards are left? Now, 51 cards are left. In the beginning, I had 52 cards. Now, I have 51 cards. But what were the chances of this 52 cards? Out of 52 cards, can I say here that probability of B, where A has already occurred, right? That is the probability of drawing a diamond card in the second draw when a diamond card has already been drawn in the first. So diamond card is already drawn in the first and the probability of drawing a diamond card in the second will be equal to 12 by 51, right? Obviously, because initially I had 52 cards, out of which 13 are diamond. One is gone. Now how much will be left? 12 cards, 12 by 51. So 4 by 17 is the answer. You can divide by 3 there. Simple. So probability of A and B is probability of A into probability of B where A has already occurred. So that is 1 by 4 multiplied by 4 by 17. Right? Multiplication. We have studied about this. 13 by 52 multiplied by, you could have done it directly also. 13 by 52 multiplied by 12 by 51. 13 by 52 for the first diamond card. 12 by 51 for the second diamond card. Even if one more time they pull out, then again you will multiply, that is 11 by 50. It's like that basically. And then solve this, you'll get the final answer as 1 by 17, right? So 1 by 17 is the final answer. Clear? Okay, let's continue. A bag contains 10 white and 15 black balls. So there is a bag that contains 10 white balls and 15 black balls. Two balls are drawn in succession, that is back to back without replacement. What is the probability that the first is white and second is black? Okay, interesting. So there are two events. So let E1 be an event of getting a white ball and let E2 be an event of getting a black ball. See, first is white. So first is white, that's why E1. Second is black, here we are taking E2. So first is already done, right? And second is also already done. That means both of them are occurring here. So required probability would be getting white ball in the first draw and getting black ball in the second draw. What they want is first is white, second is black. Okay, so from here can I say that P of A into P of B by A can be done using the multiplication theorem. Just find out the values there. So what will be the probability of A here? So probability of A, right? That is 10C1 by 25C1. We are drawing one white ball. So 10 by 25. Directly also you can do 10 by 25. 10 plus 15 is 25. 10 by 25, that is 2 by 5. Right? Now what will be the probability of B where A has already occurred? Now we are not replacing, right? So one ball will be gone. So if one ball is gone, one white ball is gone, there are 9 white balls now and there are 15 black balls. So can I say 15 by 24? Because here will be 9, here will be 15, 9 plus 15 is 24, and out of 24, how many black balls are there? 15 black balls are there. So you will get 15 by 24. 15 by 24 is nothing but 5 by 8. Now you know what you need to do here. Definitely we need to multiply these values, and once you multiply 2 by 5 into 5 by 8, you are going to get 1 by 4. Correct? You can do this directly also. See, 10 white, 15 black. Total 25. Probability of white 10 by 25. This event is done. One white ball is gone. So white balls, how many are remaining? 9. How many black balls are remaining? 15. 9 plus 15? 24. Total balls? 24. Correct? How many black balls? 15. So here I'll get 15 by 24. Just multiply these values, you're going to get 1 by 4. That's it. Simple. Let's continue. So in a group of 60 students, 20 study mathematics, 24 study computer science and 8 study both. See, whenever they say 8 study both means intersection. Are the events a student studies mathematics and a student studies computer science independent? We are supposed to identify whether they are independent or not. So let us see the solution. So A is a group where the students, okay, total are 60 students are studying mathematics. B is the group of studying computer science. So what will be the probability of A? The probability of A is going to be 20 by 60. Total number of children are 60, so 1 by 3. What is the probability of B? Probability of B is 24 by 60. 24 by 60 is nothing but 2 by 5. So probability of A is 1 by 3. Probability of B is 2 by 5. Now what is the probability of A intersection B or A and B? The probability of A and B, there are 8 children studying both. So 8 by 60, that is going to be 2 by 15, right? So now what will be the probability of A intersection B? Using the multiplication theorem, we can multiply this to get 2 by 15, right? We are getting the same value, that is probability of A into probability of B is nothing but probability of A intersection B. That means definitely the two events are independent events. Whenever they are independent events or mutually exclusive events, probability of A into probability of B is always equal to probability of A intersection B, right? Let's continue. So a class consists of 80 children, 25 of them are girls, 55 are boys, 10 of them are rich, 20 are fair complexed. What is the probability of selecting a fair complexed rich girl? Right? So this is the question. So probability, let probability of A will be the probability of selecting a fair complexioned person. So that is going to be 20 by 80, which is 1 by 4. Let B be the event of selecting rich person. How many rich people are there? 10 of them are rich. So can I say 10 by 80? So probability is 1 by 8. The probability of fair complexioned person is 1 by 4. The probability of rich person is 1 by 8. Now let C be an event of selecting a girl first. So what will be the probability of selecting a girl? 25 are girls, so 25 by 80, which is going to be 5 by 16. Now can I say A, B and C, they are independent events. So the probability of selecting a fair complexion rich girl would be probability of A into probability of B into probability of C. All three events are independent events. You just need to multiply the values. You get 5 by 512, which is nothing but 0.009, and that is your final answer. That is the probability of selecting a fair complexion rich girl. Clear and simple. Once you get the events as the independent events, just multiply all the given probabilities and you will get the answer. Okay, let's continue. Now let us talk about the Bayes theorem. Let us understand the concept of Bayes theorem first. So if S is a sample space and we have some events E1, E2, E3 up to En, all of them are mutually exclusive and exhaustive. They're mutually exclusive also, they're exhaustive also. With some random experiment, if A is any event which occurs with E1 or E2 or E3 up to En, then probability of A is given by probability of E1 times probability of A, where E1 has already occurred, plus probability of E2 into probability of A, where E2 has already occurred, up to En, provided how many events are there. Now when I say mutually exclusive and exhaustive, you need to identify which events are mutually exclusive and exhaustive. Mutually exclusive and exhaustive means exclusive, as you know, they're disjoint kind of, there is nothing common in that. Exhaustive means if you add them, you get sample space. I'll give you a simple example. Throwing a dice. If I throw a dice, how many possibilities are there? 1, 2, 3, 4, 5, 6. There are 6 possibilities when you throw a dice. Okay, now if I say getting an even number is event A, and if I say getting an odd number is event B. So event A is getting an even number, event B is getting an odd number. So even number is 2, 4, 6, odd number is 1, 3, 5. Is there anything common? Nothing is common, right? They're mutually exclusive, exhaustive. What if I add all of them? 1, 3, 5, 2, 4, 6. Do I get 1, 2, 3, 4, 5, 6? Add means not addition. If I take them together, 1, 2, 3, 4, 5, 6. Am I getting a sample space? Yes. Therefore, definitely, these are mutually exclusive and exhaustive events, right? Okay. So basically, the probability of event A, so A is an event which occurs with E1 or along with E1 or E2 up to En, right, is given by summation I is equal to 1 to N, probability of EI times probability of A, where EI has already occurred, right? Okay. Now there are 5 boys and 3 girls in room A and 3 boys and 8 girls in room B. So there are 2 rooms. There are 5 boys and 3 girls in room A and there are 3 boys and 8 girls in room B. What is the probability that a girl from one of the 2 rooms laughed loudly? This is the question. What is the probability that a girl from one of the 2 rooms laughed loudly? Okay. So let there be an event G that denotes the event that the girl laughed, right? So let E1 be an event where the girl laughed from room A. Let E1 be the event that the girl laughed from room A. As of now, we don't know, right? And let E2 be the event where the girl laughed from room B. Now, the probability that the girl laughed from room A, what will be that? Can you find out? Yes, it is going to be 3 by 8, isn't it? That is going to be 3 by 8. What is the probability that the girl laughed from room B? That is going to be 8 by 11. Now we can say that the probability that the girl laughed from either of the rooms is probability of E1 and G or E2 and G. What is G? That the girl laughed, right? So that is going to be 1 by 2 into 3 by 8 plus 1 by 2 into 8 by 11. So what are we going to get? We are going to get further 97 by 176. So 97 by 176 is the final answer, right? So the required probability is 97 by 176. Okay, let's continue. A bag contains 7 white and 3 green balls. A second bag contains 5 white and 6 green balls. One bag is selected at random. From the selected bag, one ball is drawn. Then what is the probability that the ball drawn is white? We need to find out the probability that the ball drawn is white. Firstly, let us segregate the two bags and let E1 be selecting the first bag here and E2 is basically selecting the second bag. So let A be an event of drawing a white ball. So since one of the two bags is selected randomly, we can say that the probability of E1 and the probability of E2. Firstly, probability of E1 and the probability of E2 will be 1 by 2 because one of the two bags is selected randomly and there are two bags only. Now the probability of drawing a white ball when the first bag has been chosen. So what is the probability of drawing a white ball when first bag has been chosen? That will be probability of A when E1 has already occurred, conditional probability, right? That is 7 by 10. Why? Because there are 7. And then the probability of drawing a white ball when second bag has been chosen, that is here, that is going to be 5 by 11, right? Now we can say that. So now we need to find out the total probability. So total probability of P of A is nothing but probability of E1 times probability of A where E1 has already occurred plus probability of E2 times probability of A where E2 has already occurred, right? Now you solve this further and then you get 1 by 2 multiplied by 7 by 10 plus 1 by 2 multiplied by 5 by 11. This becomes 7 by 20. This becomes 5 by 22. And finally, you get 51 by 110. So 51 by 110 is the final answer, right? This is the required probability. Let's continue. Now let us see the classical approach to probability. Let S be a sample space, then probability of the occurrence of an event E is denoted as, this we already know, isn't it? Number of elements in E by the total number of elements in S, right? That is number of favorable outcomes to E by total number of favorable outcomes. Mutually exclusive events. Now two events, A and B. Suppose you have two events are A and B. They are said to be mutually exclusive events if occurrence of any one of them excludes the occurrence of the other event. That is, if they cannot simultaneously occur. In such cases, basically this is more important, they are disjoint. As I mentioned previously, if I throw a dice and if A is an event, A is an event of getting even numbers and B is an event of getting odd numbers. So whenever we talk about even numbers and odd numbers, this is 2, 4, 6, this is 1, 3, 5. They are mutually exclusive events, right? Because they are disjoint. There is nothing common. Let us talk about exhaustive events. So if E1, E2, En are the events of a sample space, and if you take the union of all of them and you get a sample space, then definitely they are said to be exhaustive events, right? So these are exhaustive events. Then we talked about the Bayes theorem. This we already know. So let S be a sample space and E1, E2, E3, En be n mutually exclusive and exhaustive events, then the probability, right? And if A is any event which occurs with E1 or E2, then probability of EI, it can be E1, E2, E3, depends, where A has already occurred, is given by probability of EI times probability of A by EI, and then this you know the total probability as well, right? This is the total probability, correct? Let's continue. Let us see an example. So 2/3 of students in a class, 2/3 of students in a class are boys and rest are girls. It is known that the probability of the girl getting first class is 0.25 and that of a boy getting first class is 0.28. Find the probability that a student chosen at random will get first class marks in the subject. So here E1, E2 and A, there are three events, right? E1, E2, A. So let E1 be an event where a boy is chosen from the class. Let E2 be an event where a girl is chosen from the class. So E1 is the first event where boy is chosen, E2 is the second event where the girl is chosen from the class, and A be the student who gets first class marks. Now see, first class marks, a girl can get a first class mark, a boy can get a first class mark. So here we cannot define whether it's a girl or a boy. So E1 is an event that a boy is chosen, E2 is an event where a girl is chosen, and A is an event, A is this event that the student gets first class, right? So can I say probability of E1 is 2 by 3, right? Probability of E2 is 1 by 3. Why? Because there are 2/3 students are boys. So can I say 1/3 are girls? See, 2/3 are boys. The probability is 2 by 3. 1/3 are girls. So probability is 1 by 3. So can I say probability of A where E1 has already occurred is 0.28 and probability of A where E2 has already occurred is 0.25, right? Now let us use the law of probability, and then probability of event A will be probability of E1 times probability of A where E1 has already occurred plus probability of E2 times probability of A where E2 has already occurred. Just multiply the values and add them. You get 0.27, right? So 0.27 is the required probability. In a pack of 52 cards, out of 52 cards, one is lost. That means 51 are remaining. If the first 13 cards which are examined are all red, then the probability that the missing card is black is what? Okay. So let there be three events here, right? Let E1 be the event that the missing card is red. Let E2 be the event that the missing card is black. See, the missing card is either going to be red or the missing card is either going to be black, right? We don't know as of now. And let A be an event that the first 13 cards are red. A is an event that the first 13 cards are red, which is already examined, right? Which is already examined, that is, which is already occurred. So here, can we say we have to find out probability of E2 where A has already occurred? Because if you see 13 cards are already red, it is occurred, and missing card should be black, which is E2. So this is what we are supposed to find out. Now you know what you need to do here. So number of cards are 26 red, number of black cards are 26, right? So probability of E1 and probability of E2 is anyways going to be 1 by 2. The missing card has 50-50% chances, right? The missing card can be black, the missing card can be red. That doesn't really matter. So if we apply Bayes' theorem here, the probability of E2 where A has already occurred is this, right? Just put the values, get the answer now. Substitute, you know all the values here. So now you solve this, put the values correctly. Half is going to get cancelled. Ultimately, you're going to get 26C13 by 26C13 plus 25C13. You can definitely take 25C13 common from there. And then this is NCR, that is n factorial by r factorial into n minus r factorial. We have applied the formula for NCR. Then solve it further and you get 2 by 3. So what is the probability? The probability that the missing card is black is nothing but 2 by 3, right? Okay. Okay, let us have a look at an example. It says a box contains 3 red balls and 2 blue balls. You draw one ball, replace it, and then draw a second ball. What is the probability that the first ball was red given that the second ball was blue? So first ball is red, let that be event A. Second ball is blue, let that be event B. Then probability of A is 3 by 5. Probability of B where A has already occurred is 2 by 5. Now what will be probability of B where A complement has already occurred? That is the first ball is red, complement of that is going to be 2 by 5, right? So can I say probability of A complement will be 1 minus probability of A, which is nothing but 1 minus 3 by 5. 1 minus 3 by 5 is nothing but 2 by 5. So probability of A complement is 2 by 5. Now we can find out probability of B, which is very simple straight away. Probability of B where A has already occurred times probability of A. plus probability of B, where A complement has occurred, times probability of A complement. That is further equal to 2 by 5 into 3 by 5. Put the values, plus 2 by 5 into 2 by 5. That gives you 2 by 5. And then you can apply Bayes theorem. You know the formula now. Put the values here. Right? 2 by 5 will get cancelled and you'll get 3 by 5. So the final answer is 3 by 5. Let's continue further. Now let us talk about what a random variable is. So a random variable is a real valued function that assigns a numerical value to each outcome in a sample space of a random experiment. So a random variable is a real valued function that assigns a numerical value to each outcome in a sample space of a random experiment. Let us see an example. If you have two unbiased coins and if they are tossed, then find the random variable associated with that event. Now suppose two unbiased coins are tossed and x be the number of heads. X is the number of heads. Basically x is a random variable or a function. Number of heads. So can I say here the sample space as of now is going to be HH, HT, TH, TT, and we are talking about H, that is heads, and we are going to calculate the number of heads here. Now let us talk about discrete random variable and understand the definition of that. So discrete random variable takes only distinct or separate values like 0, 1, 2, 3, 4 and so on. And continuous random variables takes all the possible values in a given interval. It can be height, weight, temperature, etc. We'll get to know this better once we solve problems based on this. Alright, now let us talk about discrete random variable. So discrete random variable takes on a finite number of values. First of all, we need to understand that discrete random variable takes on a finite number of values. The probability function associated with the discrete random variable is called as PMF. The probability function associated with a discrete random variable is called as PMF. We'll see an example basically. So let S be a sample space. There are some numbers in it 0, 1, 2 and we have a table. So xi is 0, 1, 2 and here the probability of getting 1 is 0.3. The probability of getting 2 is 0.2. The question says what is the probability of getting 0? So obviously the total probability is always 1, right? The total probability is always 1. So can I say here we need to find out probability of x where x is equal to 0 and sum of probability is equal to 1. So P1 plus 0.3 plus 0.5 is equal to 1, right? That is P1 plus 0.8 is equal to 1 and then you can shift 0.8 to the other side. 1 minus 0.8 is 0.2 and P1 is going to be 0.2, right? Okay. So probability of x is 0.2. Now continuous random variable. Continuous random variable basically takes on an infinite number of values and the probability function associated with it is said to be PDF, that is probability density function. So probability distribution of a random variable. Probability distribution of a random variable, discrete random variable x, it gives the probability of each possible value of x. It will give you the probability of each possible value of x and each possible means for x1, x2, x3, x4 and so on, for which p of x is equal to xi is defined. Now let us take an example. Consider the random variable x representing the number of heads obtained in two tosses of a fair coin. The probability distribution is given by p of x when there are 0 heads is 1 by 4, correct? Because in 0 heads you have tail, so that is 1 by 4, where head is exactly 1 time, that is x is equal to 1. X is equal to 1 means what? Here we are talking about number of heads, right? So here I am talking about 0 heads, 1 head and so on. So probability of getting 1 head is 1 by 2. Probability of getting 2 heads is 1 by 4, right? That is HH, that is the only possibility, correct? So here this is x, the random variable x representing number of heads. 0 heads probability is 1 by 4, 1 head probability is 1 by 2, 2 heads probability is 1 by 4, right? Okay. Now let us take an example. The random variable z represents the number of customers arriving at a store in an hour. The probability distribution given is as follows, right? So probability of having 0 customer is 0.1, for 1 it is 0.4, For 2 it is 0.3 and for 2 it is 0.2. So calculate the probability of z less than equal to 2. Now less than equal to 2, that means this, less than equal to 2, correct? By the way, this is 3. Okay, let's continue. So for that, we need to find out the sum over here, right? That is going to be probability of z when no customer is there, probability of z when one customer is there, probability of when two customer is there. That is 0.1 plus 0.4 plus 0.3, that is 0.8. And if you add this 0.2, you're going to get 1, right? So yes, after that, sum of all the probabilities is always equal to 1. Please make a note of this. Let's continue. So here the final answer is 0.8. Now let us talk about the mean. Mean is nothing but the average, right? So how do we find out the average of a random variable? The mean or the expected value, which is also denoted as E of x or Ex basically, of a random variable x. So x is some random variable, is weighted average, right? So mean is nothing but average of all possible values of x with probabilities as weights. We'll get to know this better once we see here. So E of x or Ex. What is Ex? Ex is nothing but the mean. Mean is nothing but the average is given by mu. This is the symbol, we call it as mu basically. And then it is given by summation, addition of I is equal to 1 to n from pi xi, that is p1 x1 plus p2 x2 plus p3 x3 plus depending on how many terms are there. Okay. So let us see an example. For the random variable x representing the number of heads obtained in 2 tosses of a coin, the mean is calculated as. How do we calculate the mean of the number of heads where x represents the number of heads here, which is a random variable? It will be given by, see, summation. Summation means addition. You can see addition over here. And what are we doing? We are doing pi xi, right? We are multiplying them. 0 into 1 by 4 plus 1 into 1 by 4 plus 2 into 1 by 4. And the final value that you get is 1. Clear? Let's continue. Let us see an example here. So random variable x has following probability distribution. It is already given to us. So random variable x has the probability distribution that x, for 1 it is 2, for 2 it is 5, for 3 it is 3. We are supposed to calculate Ex, right? That is the mean. So that is given by multiplying and adding them. So just do that. This is probability, this cannot be greater than 1. So this is 0.2, this is 0.5, this is 0.3. We're supposed to calculate the mean. So take the product P1 x1, P2 x2, P3 x3. So 1 into 0.2 plus 2 into 0.5 plus 3 into 0.3, that is 0.2 plus 0.1 plus 0.9, that is 2.1. So 2.1 is the final answer. So mean is 2.1. Okay, let's continue further. Let us see one more example. A random variable x has the following probability distribution. So x, p of x, this is a, 4a, 7a, 10a, 13a, 16a. Same thing again, we are supposed to find out the value of probability of x where x is greater than 2, less than 5. Greater than 2 and less than 5. So greater than 2 is 3, less than 5 is 4. So this part, right? This is what we are supposed to find out. Okay, let us see the solution. We know that the sum of all the probabilities is always equal to 1. So can I say for p of x is equal to 0 plus x is equal to 1 plus x is equal to 2 till 5, the addition is going to be 1. 0, 1, 2, 3, 4, 5. The sum is going to be 1, right? So here we can say that a plus 4a plus 7a. From here what we can do is we can find out the value of a, right? We can find out the value of a. So let us see what is the value of a that we get here. 51a is equal to 1. So a is equal to 1 by 51. Once we get the value of a as 1 by 51, we can put it here and we can put it here because these are the only two important values for us, because x lies between 2 and 5, that is only for 3 and 4, right? So what we can do is we can have p of x where x is equal to 3 plus p of x where x is equal to 4. This gives me 10a plus 13a that is 23a, and a is nothing but 1 by 51. So 23 multiplied by 1 by 51, that is 23 by 51 is your final answer. Simple, right? Okay, let's continue. Let us talk about variance of a random variable now. So if x is a discrete random variable, x is what? X is a discrete random variable which assumes values x1, x2, x3, x4 till xn with the respective probabilities p1, p2, p3 and mean mu of a random variable, then the mean is given by summation pi xi, that is same thing again, p1 x1 plus p2 x2 plus p3 x3 up to pn xn, right? Okay. And the variance is given by variance, this is sigma square, but we read it as variance only, p1 xi minus mu the whole square plus p2 x2 minus mu the whole square up to pn xn minus mu the whole square. So basically you need to find out mu first and then put it here, right? Okay. So if I combine this, I can say the variance is given by summation I is equal to 1 to n. Why summation? Because we're adding all of them. 1 to n pn xn minus mu the whole square. Correct? Okay. And this is one of the important formula. You can make a note of this, that variance is given by summation pi xi square minus mu square. This is one of the ways of finding out the variance. Let us see an example. For the random variable y with the following probability distribution. So this is given random variable y and the probability of the random variable y is given. For 1 it is 0.3, for 2 it is 0.4, for 3 it is 0.3. Calculate the variance. You're supposed to calculate the variance here. So this is already given. Let us find out the mean first, that is summation pi into yi, that is 1 into 0.3 plus 2 into 0.4 plus 3 into 0.3. Get the answer. 0.3 plus 0.8 plus 0.9, and that is going to give you 2. So this is 2, right? Now find out the mean of y square, which is pi yi square. So here we need to square this and multiply with pi. So finally we get 4.6 after solving this. This is a basic solving only. Now you know the final formula, what you need to do here, right? So variance is given by this value minus this value. Put the values there. 4.6 minus 2 square, that is nothing but 4.6 minus 4, which is nothing but 0.6. So the variance is 0.6, right? Now let us begin with Bernoulli's trial. Let's understand the concept of Bernoulli's trial first. So the trials of a random experiment. Trials of a random experiment. That means you need a random experiment, and the trials of those random experiments are called Bernoulli's trial if they satisfy the following condition. So let us see what the conditions are. The first condition is they are finite in number. That is, the number of trials that we are doing, they should be finite in number. I'll give you a simple example. Tossing a coin 4 times. 1, 2, 3, 4. We can count that. Or throwing a dice 10 times. So they should be finite in number, right? They are independent of each other. Independent we have already studied before. Independent means our next trial should not be dependent on the previous trial. Example is again throwing a dice or tossing a coin, because if I toss a coin, I can get head or tail. Second time when I'm tossing a coin, again I can get head or tail. The outcome is not getting affected, right? Because of the previous trial. Then each trial has exactly 2 outcomes. Now this is very important. Each trial has exactly 2 outcomes, that is success or failure, right? Every trial should have 2 outcomes, success or failure. Again, the simplest example is heads and tails. You might have seen a cricket match where there is a toss going on between 2 captains. So obviously, one of the captain is going to win the toss, the other is going to lose the toss, or the other is going to win the toss and the first one is going to lose the toss, because it is heads or tails. So both of them have equal chances of success and failure, right? Okay, let's continue further. The probability of success or failure remains same in each trial. Probability of success or failure remains same in each trial. Obviously, first match is done, toss is done. In the second match, you have a new toss, right? So again, there is same success failure 50-50% chances because you can get head or tail. And the variance of the Bernoulli's random variable x is given by variance is p times 1 minus p, which is nothing but pq. Now what is this p and q? See, p is probability of success, q is probability of failure. P, always remember, whenever we will say p and q, going forward, p is nothing but probability of success and q is probability of failure. I hope this part is clear to all of you, right? Okay. Now, Bernoulli's trials have only two possible outcomes. The two possible outcomes are independent of each other. The probability of success is P. Okay, so it is already given here. The probability of success is P and the probability of failure is Q. See, if probability of success is P, right, failure is 1 minus P. Quite obviously, because failure and success, they are complementary or complement of each other, right? Okay, and the probability of each outcome in Bernoulli's trial remains the same. Probability of each outcome in the trial remains the same. So Bernoulli's trial is basically a random experiment with exactly two possible outcomes, and success is denoted by P, and as we know, failure is denoted by Q. And when probability of failure is denoted by Q is equal to 1 minus P, right? Let us have a look at an example. Biased coin is tossed. What are the outcomes? The outcome is head or tail, right? So the probability of getting head, suppose if we consider that as the success, is 0.5, then what is the probability of failure? That is, what is the probability of getting a tail? That is also 0.5, that is 1 minus 0.5, which is nothing but 0.5. So the probability of success and failure remains the same. Now let us talk about binomial distribution. So random variable x, which takes the values 0, 1, 2, 3 up to n, is said to follow binomial distribution if its probability distribution function is given by the probability NCR times p raised to r into q raised to n minus r, where r, it depends on the number of trials here, n CR, that is total number of trials, and then p and q, as you know, is nothing but the success and the failure, right? So you can see r will be equal to 0, 1, 2, 3 up to n. P and q obviously will be greater than 0, p plus q will be equal to 1 because probability of success plus probability of failure equal to 1. So let us see an example here. So fair die is thrown 6 times. So there is a dice that is thrown 6 times. If getting an odd number is success, what is the probability of at least one success? Let us see the solution. A dice is thrown how many times? 6. So here we are talking about P, which is probability of getting odd number. So what are the odd numbers from 1 to 6? Can I say the odd numbers are 1, 3 and 5? How many times is the dice thrown? Understand, the dice is not thrown only once. Dice is thrown 6 times, right? So the probability of getting an odd number is 1 by 2, isn't it? That is, the probability of success is 1 by 2. Then what will be the probability of failure? Getting an odd number, you throw the dice 1 time, 2 time, 10 time, 100 times, doesn't matter, correct? Because the probability is going to be 1 by 2 only. Even if I say probability of getting even number, and if I throw the dice for say 50 times, doesn't matter, the probability is going to be 1 by 2 only. So probability of success is 1 by 2, probability of failure is 1 by 2. Is it same? Yes, it is same. This is an example of a Bernoulli's trial, right? So let x denote be the number of success in 6 trials, right? So let x be the number of successes in 6 trials. So x is equal to 6. So x is n, right? So here n is 6. P is 1 by 2, Q is 1 by 2. We know the formula, right? So 6CR 1 by 2 raised to 6 minus R into 1 by 2 raised to R, right? So R will take the values from 0 to 6, right? Now the question says, what is the probability of at least one success, right? So as of now, for 0, it will be 6C0 1 by 2 raised to 6 minus 0 into 1 by 2 raised to 0. So for x is equal to 0, we get 1 by 2 raised to 6. That is, probability when x is equal to 0 is 1 by 64, right? Now if I talk about probability of getting at least one success, right? That is, x will be what? Greater than equal to 1. X is greater than equal to 1. So basically, if I find out the complement of greater than equal to 1, so 1, 2, 3, 4, 5, 6 is already coming in that, right? So I can take 1 minus probability of x equal to 0, that is, there is no success. That is, there is no success. So 1 minus no success means what? Greater than equal to 1, right? That is 1, 2, 3, 4, 5, 6. So put the value here, you are going to get 1 minus 1 by 64, which is nothing but 63 by 64. That is your final answer. So the probability of at least one success is 63 by 64, right? Okay, let's continue further. Now let us talk about the mean of the binomial distribution. If x is a binomial random variable with parameters n and p, then the mean of x is denoted by Ex. We have already studied that mean is denoted by Ex, and it is given by Ex is equal to n dot p, that is n into p. Let us see an example, you will understand this. A coin is tossed 10 times. Find the mean number of heads assuming the probability of each toss is 0.5. Simple. Probability of each toss is already given 0.5. N is the number of attempts which is already given, that is, a coin is tossed 10 times. So what will be E? The mean will be, number of trials is 10. The probability of success is 0.5. So here we'll use the formula, mean is N into P, that is 10 into 0.5, which is nothing but 5. So the mean is 5. Simple? Okay. And the variance of a binomial distribution is given by variance is equal to n into p into q. That is, this is like your number of trials, this is the success, and this is the failure. Success, failure, number of trials. So let us see. And q is nothing but 1 minus p, of course. So fair coin is tossed 15 times. So n is there, n is 15. Calculate the variance of the number of heads obtained in these tosses. So n is 15. We are going to talk about the probability of heads. What is the probability of getting a head? When a coin is tossed, the probability of getting a head is 1 by 2, which is 0.5. What is the probability of failure? That is also 0.5, right? So variance will be 15 into 0.5 into 0.5, right? This is also 0.5. That gives you 3.75, and 3.75 is the final answer. So I hope you enjoyed the session on probability with me, and please make sure that you also watch the previous videos as well, and we'll continue the series. Thank you so much. See you next time.